Lesson 7.6, Areas of Circles and Sectors. Let's do a quick review of what we know about circles. Alright, we said that we have across the middle of a circle and going through the center, we would have what's called the diameter. That is all the way across. If we talk about going from the center out, that was called the radius. We put two radius together, we have what's called a central angle, and a central angle cuts the circle into a piece. That's called an arc, or a piece of the circle. That is the arc. Now we're going to talk about something different this time. Before we talked about, when we talked about arc, we talked about a piece of the circumference. Now we're going to take a look at a piece of the area. So to do that, we need to have a new formula. So before, with arcs, the formula was central angle over 360 equals arc length divided by circumference, or just pi times diameter. That's what we did a lesson or two ago. Now today we're going to talk about areas of sectors. So we're going to find out the area of the inside, so a piece of a pie. And the formula for that is, nicely enough, central angle over 360, so nothing's changed. So now it's going to go area of sector, and since it's a piece of the area, we have to have the formula for the area of a circle instead of circumference, and that is pi r squared. So we're going to focus on this formula today, eventually. We're going to do a little review with just this piece first. On the area of a circle whose radius is 3. Alright, so we know the formula for the area of a circle is pi r squared. Okay, so we have a radius of 3, so pi 3 squared, which is equal to pi times 9. And if we multiply that, we get 28.26. It says round to the nearest square unit, so that would be 28 square units. We don't know what the units are, so we'll just say square units. So again, a little review of how to use the formula. Here's a picture of a farmland being irrigated. Right? So here is the well, right in the middle, and here is the irrigation unit, and that pivots around that piece of land. Therefore you have circular fields. Most of my family's from Nebraska, and this is what they do. It controls their crops a little bit better, and they are more drought resistant. Well, here's a question that says, this is a center pivot irrigation system. The moving arm sprinkles water over the circular region. How long must the arm be to water an area of this much? Now again, the area of a circle is pi times r squared. Here we have the area, 586,000 equals pi r squared. Now your radius of the circle is the irrigation arm. How do we solve for that? Well, we divide by pi. And we have r squared equals, and if we divide by 3.14, we get 186,624 based on my calculations. But it's r squared, not r. So we have to root both sides. And we get r equal to the square root of that, which is 432. And it says round to the nearest meter. So we're in meters. So that's the length. That's what the length of that arm needs to be in order to irrigate this much land. So I had to work backwards a little bit on that question. Are these equivalent? Meaning, if you plugged in numbers, would you get the same results? All right, well, if we took this problem and solved for r squared, it is being multiplied, so we would divide by pi, and yes, we would get r squared equals a over pi. So yes, they are equivalent. We've already talked about the length of an arc, all right, and then we've also then mentioned the area of a sector on the first screen. So let's take a look and see how we can apply it. Here we have a circle cut up into pieces. There's a couple ways you can do this question. I'm going to apply it to the area of a sector formula. So first of all, if you notice, we have 1, 2, 3, 4, 5, 6, 7, 8 equal pieces. They all add up to 360. So if I divide that by 8, we'll get 45 degrees. So this is 45 degrees. That's our central angle. Now we aren't asking for the arc length like we did a couple lessons ago. Now we're asking for the area of the sector, or a piece of the pie. So if you remember, the formula was the central angle over 360 equals the area of the sector divided by the area of the circle, which is pi r squared. Radius is 12. And that would be our area of the circle. So we would cross multiply these. Now if you wanted to, you could clean that up and write out pi r squared as 452.16. If you wanted to write it that way and then cross multiply it, which would be that times 45 divided by 360, and we would get 56, and they don't say round anything in particular, so I'm just going to write the whole thing, 56.52 inches squared. The other way we could have done it is to take the area of the circle, which is this, and since they're all equal, we could have divided it by 8. But I wanted to show you how this worked. Alright, last thing is, how do I take and say how much bigger is a large compared to a small? If we find the area of the big one and the area of the small one, we would get, and they wanted us to keep the symbol pi, so we're just going to write 16 squared and 12 squared. And how do I get from one to the other? Well, I say 144 times what gives me 256. So if I divide both sides by 144, we get 1.8. So it's 1.8 times bigger. And I'm running out of time, so here ends this lesson. And good luck on your assignment.